Hello class and welcome to lesson 2.2a, length of the line segment. Before we do that, we're going to do our warm-ups. Sorry about that folks, just give me a second. So for our warm-ups, ladies and gentlemen, number 1 says identify the slope formula that is used when you are given two ordered pairs that lie on the same line. So for slope, we have m equals y2 subtract y1 over x2 subtract x1. Okay, and that's based on giving two ordered pairs where A, if it's going to be x1 and then y1, and the second ordered pair is B, that'd be x2 and y2. But we'd have to give you those values instead of that, okay? All right. Number 2, use the above formula to find the slope of each of the line segments. So let's just practice that. So we're going to take slope of RS equals, again you got the formula there so you can just sub in the values, -3 minus 5 divided by 7 subtract -3. When you subtract a negative, that becomes positive. Okay, so simplifying that, ladies and gentlemen, you're going to have -8 over 10, which will equal, in lowest terms, -4 over 5. Let's try the second example. Slope of MN equals y2, which is -3. Subtract a negative becomes a positive. I want you to practice that. And then we've got -1. Again, subtract a negative becomes a positive. That's what we want to practice in this warm-up to make sure you've got your integer laws done well. Okay, simplifying, ladies and gentlemen, you're going to have 2 over 1, and that just equals slope of 2. All right, just to practice what we learned last day, state the slope of a line that's A, perpendicular to this. So first of all, we know the slope from the equation equals 3/4. And to do slope perpendicular, ladies and gentlemen, remember you do the negative reciprocal. So flip the fraction. So it's going to be 4 over 3 and change the sign. So it'll be negative. All right. Next one, it says parallel to this equation. So the equation given, slope equals 6. Okay, so therefore slope perpendicular equals 6. Great, so there's a little bit of warm-ups. And now we're going to get into length of the line. So length of a line segment, previously we've used Pythagorean theorem to find the length when we're given the diagram. Here's an example, folks. So if you take a look at this diagram, we have x, which is your hypotenuse, and we want to find that. It's going to be the hypotenuse squared equals the sum of the other two sides squared. Okay? So we would get x squared equals, if you plugged in your calculator, you're going to get 54.40. To get x by itself, remember guys, take the square root of both sides. So x equals 7.4 meters. Okay? Now we're going to apply this using the two ordered pairs. So ladies and gentlemen, if we take a look at the graph here, it says find length AB, hint draw a right triangle, and then you find the horizontal and vertical distances. So if we take point A, and connect it to point B in a straight line, that's going to be x. How do we measure that? Well, what we've done before is we've taken a look at our vertical change and our horizontal change. So I'm going to draw a right triangle, kind of like when you would do slope. Okay? And then we're going to take a look at the horizontal distances and the vertical distances. So first of all, for the vertical, okay, I'm starting at 6 and I'm ending at 2. So 6 subtract 2 equals 4. So vertical equals 4. Okay, that's 90 degrees. And now we do the horizontal. For horizontal, I'm starting at -1 and I'm going this way to 2. So -2 because we're going this way. So that's going to be -3. Okay? What the problem is here, folks, for length, we really don't have negatives that exist for length, but because we're dealing with a length measurement, you'll probably just see it as 3. So you could say it's negative if you're taking, in this case, if you're taking x2 subtract x1, okay, you could work the other way. So you could take this one, subtract this one to get that, or you could do the opposite, which would be 2 subtract negative 1, which really becomes 2 plus 1. So that's going to equal 3. Just remember, when you have length, you can't have a negative. Okay? And if you're wondering where the vertical component came from, I just took y2 subtract y1. And if you're wondering where the horizontal component, which we just did here, okay, that is x2 subtract x1. Okay? So what we have now, folks, is now we have a triangle. I just simplify it over here. I have a triangle with x. I know this is 90. I know this is 4 units in length, and this is 3 units in length. So what you can do, folks, is now I can calculate x because it's the hypotenuse. So x squared equals 4 squared plus 3 squared. Okay? Plugging this in your calculator. X squared equals 25. Take the square root of each side. X equals 5. And we'll just write down units. Awesome. Okay, that seems like a lot of work. What if we don't have a graph? Is what we're going to do now. Now we will learn a new formula that allows you to calculate the length without having to draw a diagram. So put this in a big box, ladies and gentlemen. This is the distance formula between any 2 points. Okay? Okay. And ladies and gentlemen, it's just taking a look at the square root is what you have to do at the end. So remember here, folks, you had to take the square root, so we put that in automatically. And then it's your horizontal distance and your vertical distance. Add it up, okay? Just like we did there. All right? So write this down, ladies and gentlemen. This formula is used for length, and we use capital letters for the distance or the length formula. So let's try this one. So here's an example. Okay, length of AB equals, following the example, again, if you need to write this in, x1, y1, x2, y2, you can put it in. So let's do this. So subbing it in, it's going to be 2. Subtract a negative, which is plus. That's why we did that in the warm-up. Okay? Plus y2, which is 2. Subtract y1. Okay? Don't forget your square root sign. Always start with that. So simplifying this, folks, we've got 2 plus 1, which is 3 squared. Okay? Plus 2 subtract 6, which is negative 4. It still needs a bracket because it's got a negative. Okay? Plug this in your calculator, ladies and gentlemen. 3 squared is 9 plus, be careful here, folks. When you plug in negative 4 squared, make sure you put brackets around the negative 4 in your calculator, okay? Because a negative times a negative becomes a positive, okay? Adding this up, ladies and gentlemen, 9 plus 16 is 25. Taking the square root is going to be 5. So AB equals 5 units. All right? Let's try a couple more examples, and then we'll be done. All right, determine the length to 1 decimal place of the line joining these, okay? So we don't have any visual, okay? We're just going to use the formula and sub it in. So AB equals y, I always put the square root in first, and then we're going to do the formula x2, which is 4, subtract 2 squared, plus 1 subtract 5 squared. And again, your calculator will do most of the work for you, as long as you simplify. 2 squared plus negative 4 in brackets squared. You should plug in your calculator and get 4 plus 16, and that equals root 20. And that equals approximately, that's the rounding symbol, 4.5 units. Next one, ladies and gentlemen, and guess what? Last one. Let's get her done. So CD equals, okay, x2 is 6. Subtract a negative becomes plus squared, plus 9 squared. And then we take a look at y2, which is 2, subtract 8 squared. Please start with your square root sign. That helps me remember that I've got to take the square root. So you have 15 squared plus negative 6 in brackets squared. Now you can plug that all in your calculator at once, folks. You don't need to show me all the steps. So total that together, you should get 261. And then CD equals approximately, plug in your calculator, take the square root, 16.2 units. Just going to put over here, I forgot to put AB in my final answer there. All right, ladies and gentlemen, there is the length formula. And again, it's a shortcut way of having to not draw the diagram and count the vertical distance and the horizontal distance. It's all encompassed there using Pythagorean theorem from given two-ordered pairs. Awesome. So here's your homework, folks. Page 79, numbers 1AD, 2AD, 3AD, and 5A. Have a fabulous night.